Hello there, my name is Arun Gupta and I work for Oracle. In this screencast, I will show you how you can easily run a Java EE application in the PaaS environment or Platform as a Service environment. We have built a very typical Java EE application. It's a three-tiered application. As you can see, we are using JSF or Java Server Faces for the front end, and we're using Prime Faces widgets over here, EJBs or Enterprise Java Beans for the middleware business logic, and then JPA or Java Persistence API for all the interaction with the database. Now, this application may optionally contain services metadata, and we'll take a look at that in a second. But then this application as a whole could be deployed to GlassFish, which is the reference implementation of Java EE 7 as it evolves, and is going to be deployed over there. But today, services metadata is a GlassFish specific artifact, and it may look like as shown here. So you can have service description, different configurations, and different metrics specified over here. So let's take a look at the application first. The application here is shown in NetBeans IDE, and it's built as a Maven-based application. You can see there are a whole bunch of XHTML pages, which is the typical templating language for JSF 2.0. We have source code over here. There are a whole bunch of beans, which are acting as the middleware business logic. And then, of course, we have our JPA entities, which talks to the database. And we have our persistence.xml and other dependent files. I have already built this application by giving a simple command of maven clean install, and that already packages the file for me. Now let me walk you through how we're going to install or how we're going to deploy this WAR file into the GlassFish recent builds. So the first thing we do is we go to download.java.net/glassfish. It's download.java.net/glassfish. We go to version 4.0. Click on the promoted link. The latest promoted build right now is GlassFish 4.0 Web 4.0. So we can download the build over here. These are the web profile builds, and this is the full build. So I've downloaded the full build for now, and I've downloaded it for convenience already. Now let me walk you through the installation of this build. I have an installation script. In this installation script, I use the build number, which is B04. I set GlassFish and ASAdmin variables. I do some cleanup. This allows you to repeat the script again and again. This is on Windows, so use a command line to unzip the bundle. I copy a platform-specific load balancer.zip file, which is available to you as part of this blog, or on the page glassfish.org/JavaOne 2011. Then I copy a derby.properties file, which is also available from that page, so that our SQL statements that are executed are displayed to us. Then I start my domain. Now I also enable PaaS console. This is a new component in GlassFish. This allows you to deploy your applications in a PaaS environment very easily. Then I also create a IMS config native, IMS standing for IaaS management service. Now GlassFish can be configured in two different modes. One is a native mode, wherein all the services are provisioned within the laptop environment, very useful for development debugging environment. And another mode is virtualization mode, wherein you actually start using the services in a virtualized environment. And then I create a template for the load balancer. Again, this time the type is native. And finally, I give an optional command, which basically says, provision all these services in parallel for me. So this speeds up the provisioning of the services. Okay. So having seen the commands here, let's issue the install script. It unzips the package, starting my domain file. My domain here, the lb.zip has been copied successfully. And we can also start tailing the log. So this shows, as the different templates or commands are being issued on the domain administration server. So okay, now our GlassFish DAS has started. So let's go to the browser and let's take a look at our PaaS console. This is available at the URL of 8080 PaaS-console. So if I click on that, this is how the PaaS console looks like. Take the default username and password. This will show you the list of applications that are already deployed here. In the native mode, today we support only one application to be deployed. So I can click on deploy here. The very first step is to, of course, upload the application. Now, as I showed you earlier, the application is a very typical Java EE application, does not contain any application server specific artifacts or any proprietary components. So we click on browse, go to target directory. This is the WAR file we generated. Takes the application name, context root, everything else is default. Click on next. Now at this time, our PaaS console, so to say, goes and talks to an orchestrator engine, which is sitting in the GlassFish. And it says, okay, this is a WAR file. So the orchestrator engine says, I'm going to provision a Java EE service for you. And it also says the cluster size, the min and the max for the cluster size, which could be auto-scaled to meet the increasing demands, keeping the same quality of service. It also provisions a load balancer for you, again, this time in the native mode, because that's the template we created. And it realizes by querying the WAR file, so it also provisions the RDBMS service. And by the way, as part of this, it also creates the JDBC connection pools and resources that are required to be provisioned for you. And as part of the RDBMS service, it provides a hook by which you can generate your table structures and also populate them. So let's point to that SQL file for us. And then we click on next. It confirms all the values with us, and we click on deploy again. And if we look back here, we can look at the server console as the services are being provisioned for us. Now this by itself is not very useful. So let me go back to the slides. Now in the slides, what you could see is all of these services are automatically provisioned for us. So as I said, the orchestrator engine looks at the WAR file, it starts provisioning the Java EE virtual machines for you. So it says 1, 2, or you could always override the value of the number of virtual machines that needs to be provisioned for you. So it could be 1 to n. They together form a cluster of the virtual machines. Then a database service is provisioned for you automatically. The SQL hook that we talked about is being run. So this allows you to create your table structures and populate them as well. And finally, there's a load balancer as well. And all of this, of course, is running within a cloud environment. And what I'm showing you right now is doing all of this on a single laptop. There is no connectivity with the outside world so far. So all of this is happening on the laptop environment, which is very useful for all the development debugging on how the service provisioning works, basically. And then later on, I'll also show you how this same environment can be seamlessly migrated to your private cloud if you want to go deployment. Okay, so let's take a look back at our GlassFish server control. And our application is successfully deployed. Now let's access our application and see, how does it look like. So here is the application name, first of all. So we click on the application name, and it shows us the context root, the different URLs associated with the application. And as you can see, this is my load balancer URL. It shows multiple instances being provisioned for me. The key difference being this is HTTP, this is HTTPS, and there are 2 instances, as we saw earlier, are being provisioned automatically. And under here, it also gives you the symbolic names of the different services that are provisioned. And as you can see, there's a cluster created for you for these 2 cluster instances, and there's a database instance, and there's a load balancer instance. Okay, so let's click on the load balancer URL, and this brings up our application. So this is an application, as we said, it's about conference planning. So each conference has different aspects that can be tracked. For example, there are different tracks in an conference, so you can say show tracks. Now we are using the data from JavaOne, so it shows you all the tracks in JavaOne. Now I could click, for example, on enterprise service architectures and the cloud, and it will show you all the sessions in that track. Now I could further say, show me more details about this session, and it could show you, for example, the speaker and the company, and we could actually build upon this application very easily. Similarly, I could say, show me speakers. Then it will start showing you all the speakers. And then again, you can say, click on a speaker name, and it will show you their sessions. And same thing, we can click on show sessions, and it will show you all the sessions. And you can click on any particular session, and it will show you who's giving that session. Now the fun part is wherein I have pre-registered attendees as part of the SQL. So let's log in as that attendee. So I'm gonna enter the username as Arun Gupta and a very trivial password. So click on login, and I am logged in. Okay. Now I see a new item here called as my schedule. So let's click on edit schedule, and here I don't have any items in my schedule, but I'm presented here with a text box. So if I click on, for example, enter the text GlassFish, my search starts narrowing to the list of sessions that have GlassFish in their title. Okay. So here I can sort them, for example, or let's say you want to attend the GlassFish community event or a hands-on lab. So you can click on add here, and that particular session will actually get added to your schedule. Okay. Now the important part to notice here is it also gives you some debug data here saying is served by Cloud 3 instance on so and so host. Now this is my host, but this is the instance that is created for us. So let's go back to the PaaS console and click on environments and look at our environment name. And here we'll see Cloud 3 and Cloud 4 are two instance names. So if we look back here, it's served by Cloud 3 instance. And if I go back here, if I stop the instance, for example, if I go back to my application, now this application was served by Cloud 3 instance. If I go back here and refresh the page, this request still goes back to the load balancer, which figures out that the Cloud 3 instance is down, and this time it's automatically served by Cloud 4 instance. So the cluster that is provisioned to you is by default highly available, and your sessions failover automatically happen. So far we have seen how GlassFish provides dynamic service provisioning, where the services are automatically provisioned for you, and we also see how the Java EE cluster that is created for you is highly available by showing a session failover. Now let's take a look at this development environment, which was running all on your local laptop. Once it is migrated to a private cloud, what the user experience looks like. So for that, I have a setup that is already being done for me. I have a bunch of Oracle virtual machine instances running. And then here what we are looking at is GlassFish application server control, or as we were referring as PaaS console, which is running on that instance. Now this is accessible at the URL, same URL basically, so the host :8080 PaaS console, and we log in there. Once we log in, we get the same view over here. Application, environment. Let's click on the application here. Once I click on the application, I see the same set of details. My context root, same load balancer URL, same different instances, HTTP, secure HTTP, and different set of services provided for me. So your view of the development environment and the production environment is pretty similar, which is kind of cool. Now, if I click on the application here itself, my application loads up pretty fast. Now again, this is the URL of the load balancer, and here is showing me what my instance name is, what host it's running on. So just like last time, we have all the tracks, speakers, sessions, all those information available here as well. So for example, I could again click on, let's say, a different track this time, and this time it will show me how the different sessions are in that particular track. Now, one thing that I want to highlight here is how in the virtualized environment, or even in the native environment for that sake, we can easily adapt to the increased load and yet maintain the same quality of service. And that we achieve very easily using auto scaling. So if I go back here in my PaaS console, I click on my environment, and I click on auto scaling tab here. Here, by default, this is minimum instance count 2, maximum 4. If I want, I can do manual scaling by increasing these counts, and this would take into account. But what I'm going to show you is how this auto scaling triggers into account by taking into consideration that if any instance in the cluster is having more than 50% of memory threshold, then it's going to just spin up a new instance to handle the additional number of concurrent users, most likely. So if we go back to our application here, I can click on home, go to load, and here, in order to simulate that number of concurrent users or increase traffic to your website, I have a simple button called as increase load. Now, this is only a demo, so it's not a real use case, but that's the idea. You will have a sustained traffic over a period of time, and then you want to maintain the same quality of service. So when I click on increase load over here, it's going to add a 256 megabyte array to my session. So how do we demonstrate that? Go back in the PaaS console, and as I said, we also display some nice monitoring charts here. So once I click on the monitoring tab, it shows me all the charts. Here it shows me my 2 instances have been provisioned so far. It shows me their JVM memory usage statistics as well, in megabytes, how much they are going, and the timestamps. Now if I go back to my application here, I click on this increase loads button. Here it has added a 256 megabyte array to my session. Go back to the console, and once the charts are refreshed, and here you see a spike right away, in my memory usage. Now, how do we monitor this? So what I'm going to do is I'm going to open OVM Manager. And here you can see Conference Planner 1, 2, 3, and 4. 4 instances are running right now, which is to handle my 2 Java EE virtual machines, 1 database, and 1 load balancer. Now, if I click refresh here you can see a new instance is already being created to handle the same quality of service and ensure that auto scaling works actually very well. So if I go back here, you'll see the load still stays here. And so the process that happens in the background is it spins up an Oracle VM instance, then it starts installing all the required software over there, and eventually we will see this graph showing an uptick, basically indicating that a new GlassFish instance has been created here as well. So the idea is, you can create your own metrics, you can create your own thresholds, memory usage, you can use your regular expressions and other metrics that will be added to the platform and to the GlassFish implementation itself. And those would allow you to define your own metrics based upon which you can show additional instances. Finally, I would like to conclude by summarizing. This screencast demonstrated GlassFish as a PaaS solution, dynamically provisioning services such as Java EE, database, and load balancer, either implicitly by introspecting the application archive, as was the case in this demo, or explicitly by specifying their value in the services metadata file. In future, the Java EE 7 expert group will provide a standard way to specify that information in a file. Now, the services may be provisioned as part of an application deployment itself, or a deployment can use pre-provisioned services that could be shared across multiple applications. Secondly, we saw that the Java EE cluster was configured for high availability and session failover capabilities. The application demonstrated that when the login information that was stored in the HTTP session was available even after the instance serving the page was terminated. And finally, the application demonstrated how elasticity can help you meet growing demands as the user base grows in a linear, scalable fashion. This requires the ability to dynamically grow or shrink the number of services or resources. And that's exactly where elasticity capability provides auto-scaling to either dynamically scale up, which is in a vertical fashion, scale out in a horizontal fashion, and scale down as the demand changes. The application demonstrated that when an instance went over the memory threshold, the JVM memory alert was triggered in the elasticity module, and as a result, an additional instance was automatically started by the OVM manager. You can go to glassfish.org/JavaOne 2011 for complete details about this demo, and thank you very much for listening.